everyone, and welcome to Let's Talk MLOps. My name is Becky, and I'm on a mission to find out the latest trends, challenges, and prospects within machine learning, and with a particular focus on machine learning operations, or MLOps. Throughout this series, I'll be talking to experts within the field who will share their knowledge as well as advice for implementing, monitoring, and scaling successful machine learning practices. Hello, everyone, and welcome to Let's Talk MLOps. I'm super excited to be joined today by Jamie Curtis, who is practice lead for machine learning and MLOps at Datatonic. Jamie, thank you so much for joining today. Could you tell us a little bit more?
Sure. Yeah, well, thank you for having me. I'm Jamie, as you very kindly introduced. I am the practice lead for machine learning and MLOps at Datatonic. Who are Datatonic? We're a small company. We're a specialist data and AI consultancy. We hold multiple partnerships, but the primary partnership that we hold is with Google Cloud. So most of the work that we do is on Google Cloud platform. And my role within Datatonic is to oversee the machine learning practice. That means I'm accountable for the operational, the strategic, and the commercial performance of our machine learning solutions. And of those solutions, we typically deliver solutions around data science, ML ops, ML engineering, includes DevOps as well. So multiple solutions within the field of machine learning and ML ops.
Awesome. Fantastic. Thank you. I think a really nice place to start, would be, starting with your personal journey into MLOps. I know it's a relatively new term and field specifically, but how did it start? How did you get into it, and what interested you?
Yeah, sure. So I have to say I kind of fell into it quite strangely. I love it now, but it wasn't really by design. I have an engineering background, so I studied chemical engineering as an undergraduate and master's degree, but then moved quickly into business consulting out of university. So I'm not an engineer, in the sense that of a kind of machine learning engineer or data scientist or software engineer or anything like that. But I entered MLOps certainly far more from the business side. So from moving from business consulting into tech and data consulting, where we are at Datatonic, and then now more into kind of leading the practice from a strategic standpoint in particular, but obviously needing to draw on both commercial and technical expertise from people around me.
Yeah, awesome. And going right back to the basics then, in the last sort of 7 to 8 months that I've been, researching MLOps and learning as much as I can, I've come across so many different definitions, and everyone seems to have a different one, with many different aspects and skill sets. How would you define MLOps for those who haven't joined it yet?
Yeah, sure. So I think there's a technical way of defining it, which would be something like around creating a robust and standardized system, complete system for machine learning workloads to run in production. It'd be something like that. But it would basically be the concept of enabling machine learning models that are often created by a data scientist to be deployed and monitored in production, and to be iterated upon, and to be stable and secure and things like that. Like I say, I love to come at MLOps and machine learning from a business perspective. So if I was to then define it as well from a business perspective, it's fundamentally about increasing the return on investment that you get from your data science investments. So it's around looking at data science and thinking, how can we make that an investment which returns more? That ultimately for me is what MLOps should provide, is the ability to make your data science investments more profitable.
Yeah. So then there's like the technical, from a technical perspective, like you said, from a business perspective, would it be fair to say there's a culture, sort of a culture perspective as well, when it comes to like I don't know, from what I've understood, that sort of feedback loop or communicative loop. Is that right? Have I understood correctly, sort of that
Yeah,
culture side?
Yeah, for sure, for sure. There's also I see MLOps as a way to bridge the gap between data science and ops, I guess, or what people might define as, software engineers or internal IT operations teams, or perhaps even like site reliability engineers. But there historically has been a gap between the skill sets that a data scientist has, which will be around statistics, machine learning techniques, kind of the maths fundamentals, and the skill sets that a DevOps engineer or software engineer might have, which are around automated testing, CI/CD, infrastructure as code. And there's a gap really between those two disciplines, but there needs to not be a gap if you want to have machine learning running in production. So MLOps, and I guess the birth of the role of machine learning engineering, or the MLE role, which is I think kind of a coined term now, that is the birth of that role is almost designed to close that gap between data science and software engineering.
Does that mean that sort of the ideal MLOps engineer, let's say, needs to have both of those skill sets, like to the max? Because that it could be quite a lot to ask from one person, if that makes sense. It's a lot of skills, right? Or
yeah, it's not saying that you need to have all of both, but it's saying that you need to be kind of I think the term is T-shaped enough that you understand enough of.
Yeah.
So having an understanding of on the data science as a machine learning engineer, having an understanding of on the data science side, things like data validation, evaluating models, what metrics should we be looking at to evaluate, to understand that the model is performing. Is F1 score enough, or do we need to look at, there's hundreds of metrics that you can look at to evaluate the performance of the model. That's on the data science side. On the software engineering side, like I say, it's around like CI/CD, containerization, infrastructure as code. Perhaps you need to understand Terraform to be able to do that. And so, for me, the best machine learning engineers are people who understand enough of both to be able to create machine learning workloads and run them in production.
Sure, that makes sense. And do you think there's also value in organizations that have the means to do so, bringing on multiple MLOps engineers onto the team that may come from these different backgrounds? Is there value in that?
Yeah, for sure, for sure. It really depends how you want to set up your organization. And for me, one of the big decisions an organization needs to make is how centralized or decentralized they make their ML engineering function, or the MLOps function, whatever you want to call it. Because data science is typically quite decentralized in the sense that you often don't have just a core data science team. What you'll have is data scientists embedded in your business function. So you might have a data scientist who is an expert in marketing, or you might have a data scientist who is an expert in time series forecasting. But what you then often have by contrast is kind of a central, say, software engineering team or platform engineering team. And so if you imagine you've got this central team here, but then you've got kind of your decentralized data science teams here, you need to work out where you want to put your ML engineers. Do you decentralize them and have one ML engineer sit alongside all of your data scientists? Or do you centralize them and try and have an ML engineer serve the needs of multiple data scientists? And that answers the answer to that question will answer your question. So if you want to decentralize your ML engineering function, then you will probably need more ML engineers, but you'll probably have more flexibility and more kind of customization towards the specific data science needs that you have. If you want to centralize it, then you probably need less ML engineers, but you will be a bit more rigid in what you're able to offer all of your ML engineers.
Thank you. So another point that I thought would be really interesting to touch upon is the article that you wrote recently, MLOps in 2023. I've had a look through. It's really fascinating, and I was hoping you might be able to tell us a bit about the main maybe trends, also some challenges, and basically what you foresee coming, over the next months.
Yeah, for sure. Testing me a bit now on what I'd actually written at the time, but
Ah.
uh, hopefully I can remember off the top of my head. So data centricity
Mm,
and the importance of data on machine learning and MLOps will definitely be one.
mm,
Um, the kind of buzzwords that have been thrown around for maybe the past year, maybe even the past 18 months, are around kind of data mesh.
mm,
Now things like data contracts coming in. And basically the whole premise behind that is around ensuring that data is of adequate quality and adequate accessibility
mm.
by machine learning practitioners, be
Okay.
that data scientists or machine learning engineers.
Awesome. And then, so I suppose in your team specifically, what are the sort of the main challenges, MLOps specific challenges that you're seeing a lot at the minute that other teams might be able to resonate with?
Um, sure, definitely there is a theme around making data science more accessible, but basically reducing the entry barriers for data scientists. And when I say that, I mean the entry barriers for them to adopt an MLOps way of working. So ensuring that they are following best practices throughout the ML lifecycle. So
Mhm.
using things like Git to store all their code. That for a software engineer is just the most part and parcel thing of their day. Like what you'd almost, a software engineer might say, well, where else would you even store code? Whereas
Yeah.
for a lot of data scientists who are doing things like offline experimentation, they will store code locally on their laptop and just kind of play around in it there. So yeah, there's a theme definitely we're seeing around reducing the entry barriers for data scientists to adopt kind of best practice MLOps way of working.
Oh, interesting. And is that across all, MLOps teams, would you say, or does that affect some organizations more than others?
Good question. I think it would affect some organizations more than others. A lot of it depends on the maturity of your existing data science function,
Mm.
and how used to how used to working in a kind of engineering focused way that they are. If they're used to working in a way that is uh, quite siloed from the business and doesn't lend itself towards productionizing your machine learning workloads. For example, they've only ever done offline experimentation in a notebook somewhere, then it will be quite difficult for them to overcome the hurdles or the entry barriers required to get closer to the kind of software engineering and platform engineering side of the business.
Okay, nice.
Yeah, I think it does depend on the business, and
Mhm.
it would depend definitely on the uh, data science maturity of the business.
Okay, yeah, that makes sense. Thank you for explaining. From a leadership perspective, as a lead yourself, do you have any tips then, for people leading MLOps teams? We spoke before about, some of the different backgrounds the engineers may have or some of the challenges. Are there any tips you have that leaders, can bear in mind or things that might help them with that process or things that you implement, as a lead yourself?
I think there are things relevant to specific skill sets. And I actually made a LinkedIn comment about this probably only 2 hours ago, which is quite
Oh, okay.
quite strange asking. But for me, the most fundamental skill needed for leading an MLOps team or any technical team. Not, by the way, I should caveat, I don't lead a technical team. The team that I lead is more strategic and commercially
Mhm.
focused, but we do work very heavily with our technical teams. And to be able to collaborate and work well, And I guess naturally, like I say, not that I've led a technical team, but to be able to lead a technical team, I think the most fundamental skill is the ability to communicate with people on a kind of within a common language or in a common way. And the reason for that is because if you are a leader within any team, you ultimately serve, or your goal is to serve the business of which you're leading, right? But equally, to do that, you need to lead and to delegate to the team below you. In order to be able to understand the business, you need to understand terms like ROI or EBITDA. Equally, in order to be able to understand your technical teams, you need to be able to understand terms like CI/CD or JSON-L or YAML. And if you can't understand, or if you can only understand one of those things, then you're just adding to the gap in communication between the business and the tech.
And that's what MLOps is kind of trying to change, right? From what I've understood, it's all about that, bring them together.
Yeah, for sure. Specifically with MLOps, it's around bringing together kind of data science use cases with the kind of engineering fundamentals that are needed to have those data science use cases actually adding value to your business. But more broadly, I think for any leader in any technically focused role or any role that exposes itself to technical teams at any point, the ability to communicate between the business and the tech is just so fundamental.
Awesome. And then specifically from a business perspective, I know you've gone into it slightly. What would you say are the main benefits for an organization to work on implementing more MLOps practices than maybe they've had? I can't remember the specific name. I know that there are different levels, aren't there, of integration. I think, is it maybe 4 sort of how much MLOps is implemented in a business? Forgive me, I can't remember the exact names, but
no worries. There's, to be honest, you could be referencing one of maybe 5 or 6.
Yeah, exactly. I've seen a few
different kind of like maturity frameworks or maturity assessments. So, like I say, at Datatonic, we are a Google Cloud partner. So most of the way that we would define the MLOps maturity assessment is the one that's driven by Google Cloud. I think they have 3. It's like a level 0, level 1, and level 2. But I know Microsoft Azure have their own, NVIDIA probably have their own as well. So yeah, loads of these kind of big players and big professional services firms as well will have their own kind of twist on a MLOps maturity assessment.
And what would you say are the benefits then, the main from a business perspective of maybe improving, or working more on the MLOps factor?
Yeah, absolutely. This is actually kind of, like I say, most of my thinking about MLOps as a concept is around the answer to that question. It's like, okay, we've got this cool concept that's come out, but really, like, what are the business benefits that it can provide to our customers? And the way that I think about it in my head is to do the comparison of what the value life cycle of so you basically, if you plotted a graph of value over time, to think about how that would look for a data science use case without any MLOps versus how it would look with MLOps in place. And the differences are quite stark. It's obviously, I have some diagrams somewhere that I wouldn't be able to show you in quick time at least, but you can basically imagine that it takes a long time for your data science model to even get into production, because for whatever reason you aren't able to deploy it, or your data science team have built a model that can't be engineered in a way that can then run sufficiently in production. Once it's in production, your data science model probably degrades almost instantly. Depends on the model, but most models will degrade over time. Then you might have some sort of model failure, whereby, I don't know, a Python package update happens and you haven't accounted for it, or you didn't know it was happening. So then you need to roll your model back. And basically all of these events in time happen to your data science model that you hope is running perfectly in production, but all they're doing is causing your model performance to degrade. Whereas with MLOps, what it aims to do is get your model into production much earlier and to have it stay at a higher level of performance once it's there. So to get it in earlier, it has kind of automated, standardized processes to ensure that you can deploy your model to production at an earlier stage. And then to have it stay performant whilst it's there, you can have things like automated retraining, complex or sophisticated serving methods like shadow deployment or champion challenger deployment. You can have monitoring, of course, to ensure that when it does degrade, you can see that it's happening and you can go in and rebuild some features or tune it in a different way. So MLOps is all around looking at what the life cycle of a data science use case looks like without any MLOps and all the events that could cause it to degrade in its performance, and then to do things, automate processes or create kind of standardization to ensure that those events have as minimal effect as possible.
Awesome. And in terms of those stages that we talked about, there are like 5 or 6 variations. So let's say, an organization is watching this and they feel like they haven't implemented much yet. Do you know roughly how long it takes sort of to go through from one stage to the next? I imagine it depends, but is it possible to sort of get to a really high level of implementation quite quickly, or is it a very lengthy process?
Yeah. It really depends, one, on your use case, and two, what you want to achieve. So if you have a simplistic use case that can be served by, AutoML, whereby you don't even really need to be a data scientist to create your machine learning model, you just find some an AutoML that will compare multiple model types for you and spit out the best one. If you have a simple use case that can be served by AutoML, that has a simple data feed coming in and has very little likelihood of degradation, then you can probably serve or have your model running in production in a matter of weeks, maybe even 1 or 2 weeks.
Yeah.
Equally, if you have very complex model that has embeddings and relies on very custom neural network to run, has very low latency requirements, for example. So, it needs to serve in milliseconds. A lot of fraud detection models are very similar to that. They have to serve results in, milliseconds or even less. Then the ability to deploy your model and have it run accurately and sustainably in production is very much hindered. So at that point, you could be looking at 6 to 9 months to have one single model built and deployed, or longer. We have clients who build very complex models and it takes them 18 months.
Sure, yeah, I suppose, yeah. So there must be a massive variation in depending on the company's size and needs, but that's a good sort of, at least, so they have an idea of what it might look like. I think that's really useful. Thank you. I think an awesome question to end on, and that can be MLOps related or just general AI related, or a way that fits in both, would be, in your opinion, what's the most exciting thing going on, or what do you feel most excited about or most passionate about that's happening over the next few months? I know, feel free, we can talk about it, but I know everyone, of course, is talking about ChatGPT. We can still talk about it, but there are lots of exciting things going on. What's exciting you the most?
So it's actually not ChatGPT. It is obviously incredible, like as in terms of certainly in terms of a marketing tool and getting people talking about it. It's definitely broken down the barrier, I think, of making AI more accessible. The thing I am most excited about, though, personally, is and I actually strangely think the downturn in economy might increase this or accelerate this, will be the emphasis on delivering real return on investment from data science use cases. Okay. So what I mean by that is a lot of companies will experiment with data science under the almost kind of like a blind assumption that it will generate value, and actually it should do in most cases if you've picked your use case correctly, but that's not always the case, and a lot of often strategic work is needed up front, and kind of things like use case discovery to ensure that you've picked a use case that will solve your business need, and then that you've built it in a way that it delivers real return on investment, and you've built it in a way that you can actually track that return on investment and the cost of running the use case and things like that. So I think the impetus will increase on tracking effectively kind of financial inputs and outputs that are going in towards data science efforts.
Oh, awesome. No, that's really interesting. Like I said, like you said, everyone, to go just slightly steering away from the chat GPT and talk about something that, like you said, interestingly, may become more apparent after, the downturn and everything. So that's a really cool, slightly different topic to bring on the table. Thank you so much. I'm afraid that's all we've got time for today. Thank you so much, Jamie, for joining, sharing your, all of your tips, especially from such an interesting perspective as from the business side of MLOps. That's really fascinating. So thank you very much. Thank you to everyone watching as well. I really hope that you enjoyed today's episode. See you soon. Let's end with a little bit about Logic. At Logic, we recruit specifically within the machine learning engineering and research fields in the UK, Canada, and the US. We pride ourselves on our innovative, community-led approach and having a deep knowledge and understanding of the roles that we recruit for. That's one of the reasons why I've started this podcast. If you're looking for your next professional challenge, or on the other hand, you might be an organization looking to expand your machine learning team, then please feel free to connect with me on LinkedIn and send me a message. Alternatively, you can send me an email to becky@logic.com. Let's set up a call for a chat, or we can meet in person for a coffee.